So good morning again, one more time, and let us continue with the next point. So if you can recall, last time we were talking about something like a collection. We have talked about what exactly the decorator is, not decorator actually, but we have seen something like a function within a function. We have seen different stuff like, for example, you can have a outer function, we can have an inner function, and we also have seen maybe a feature where inner function can access all the members of outer function. So this is something we have already explored last time. So today we want to continue further, and in today's example, you will see how to use a kind of next generation or maybe the next type of code, which will kind of make your life a little bit easier, but not directly. I mean, that's a little bit difficult to digest for the first time, but believe me, once you understand that, it's the simplest concept and it's very powerful concept that you are going to see later. I mean, today for demonstration, it's okay. Maybe we can use some simple examples, but later, once you start writing your real-time code or maybe the production-related code, you will see the feature which we are going to explore today is going to be very, very, very helpful. So this is what we are going to start. This feature is called as a decorator. So let us see what that decorator is. Let me just go back here and see. Oh, I didn't mention anything here. It's okay, not a big deal. We'll update it as we go. Okay. Okay. So let us quickly execute the code what we have seen last time. So I hope you can recall. This is the code we were looking at last time. So we were saying something like a function like outer. I'm sorry, like an outer, and inside that outer we were declaring some variables, something like num is equals to 100, for example, and we were writing one more function within it. It's called as a simple like inner function. Maybe just to be precise, I want to say like inside outer. So we can see when we are going in outer and when we are going in inner. So this is an outer function. And here I'll say inside inner, inside inner, that's it. So inside inner, I wanted to access the variable value num. So I would say something like num is equals to num. So I wanted to try whether I can access the variable num in outer as well as in inner function, something like this. Now, probably you can easily guess that because num is declared within the function, this is a local member of that function. When I say local member, num can be accessed only within that function itself. You cannot access it outside the function. So this is something that we already have seen last time. A variable which is declared outside any function is called as a global, and a variable which is declared inside a function is called as a local. Now, if you pay attention to this line number 8, where we are declaring a function, probably you can recall the function internally will create a variable called as inner, and it will point to another object where the function body will get loaded. That means internally inner is also considered as a variable. And because it is declared inside the function, that will also have a local scope. Now, probably if you can recall, we were talking about two scopes. One was something like a local and the other one was something like a global. And if you can again recall, I said that by default, you cannot modify the global values inside a function. If you want to do that, you have to use a global keyword. So this is something what we have explored last time. Here, I want to just go back and call that outer function, and you will notice that only outer function will be called. You see, I'm going inside the outer function. I'm able to access that num. So everything is going as per our expectation. But nowhere I see something like inner, so inside inner and the num is equals to 100. So I want to see those two statements as well. In other words, I want to make a call to that function inner. So you know that you cannot just call this function outside this outer function because right here, inner is not visible. If I try to forcefully call that function, Python would complain that and Python would say inner is not defined here. So inner is not a function which can be called outside the outer. Inner has to be called inside the inner, inside the outer function. So here I can make a call and say run, and probably now I can see I'm going inside the outer. From outer function, I'm calling inner function, and then I'm able to access all the members of outer function. So the rule what we have seen last time, like inner can access all the members, all the members of outer function. So this is something what we have already explored last time. So now when you talk about the inner and outer, this is the kind of relationship you will see. Outer is a function which is having variables, or you can say inner functions, and inner function is the one which is declared within outer function. I also have mentioned there is no restriction on the hierarchy. I mean, outer can have inner, inner can have inner, that inner can have again one more inner, and you can go as deep as you want. At the same time, you can have many inner functions in outer function as well. So here for demonstration, I'm using only one, but again, it's not a restriction. You can have as many inner functions as you need, again, depending on your requirement. Please keep this in your mind because this is something that we are going to use in the very next feature for is object-oriented programming. But before we go to object-oriented, we have to first explore what exactly this decorator is. So let us start with this now. Now you know that this is outer and inner. The scope of this inner function is local, so you cannot call it outside that outer function. This is something what we have just said a minute before. Now, hopefully you can recall, maybe I'm just trying to give you two different contexts and I want to relate them together by using a decorator function. Okay, so see what I'm going to say here. So probably I'm going to say that I have a function called as a add, for example, which is going to have that P1 and P2. That's parameters we are passing to that add, and I'm going to return P1 plus P2. That's it. Or precisely speaking, I want to put the P1 plus P2 like this way. So P1 plus P2 is equals to P1 plus P2. So that will be crystal clear that this is an addition, you know. So I can have one more, something like subtraction or subtract, and I'll say P1 minus P2, and here I'll say P1 minus P2. So that's it. We are having addition and subtraction. I hope you can recall the same example we talked about last time. I said this is addition and say 20, 10, and this is subtraction, let's say again 20 and 10. So probably when I say run both of these codes, I see nothing just because I'm not printing anything inside the function, I'm returning the values. Nevertheless, even if you print the details, let's say print this and print this, probably you can recall it is just going to say 10 plus or 20 plus 10 is 30 and 20 minus 10 is 10. That's it. But I want to decorate the result. Now, how do you decorate the result? To decorate the result, you can literally modify this code. But again, if you can recall, I said you don't have to modify the code. Rather, you should not modify the original code, because in case if you really want to use it with the original condition or original output like this, you still can do it. And if you want to achieve the decoration on top of it, probably you can easily do it with the help of another function. Could be something like an execute function. So if you can recall this way to call that function execute, this is the way we were doing it last time, and we were calling something like this as a function. So actually probably you can say that this is a kind of a execute function which is going to take one function as an input parameter, and this function is going to put all the decoration what you want to put there. So probably I was thinking about to have, let's say 40 dashes like this, maybe before calling the function, after calling the function, and then here I wanted to call that function, sorry, the function, and I wanted to pass the parameters like 20 and 10. Again, instead of calling the original function, now we need to call that execute function by using a add as a function reference, and second one is something like a subtract. So again, subtract is the function reference we are passing. So probably when I say run, you would notice that my decoration is kind of enabled, and still I have not modified my original code. So everything is going as per our expectation. So probably when you are thinking about a scenario, we are having two different scenarios here. In one scenario, we are having an outer function and inner function, and we have seen the relationship. And in another example, we are having an execute function, which is accepting a function parameter and which is making a call to those functions based on the reference we are passing at the time of calling that execute function. So this is something that we already have seen last time. We are just quickly revising them. So probably if you see that, it looks good. I mean, it's something like it is working right now. But there is only one problem. The problem with this scenario is like, instead of calling the original function add, we have to call that function execute all the time. In a sense, we have to let our caller know that, hey, don't call that add or execute, add or subtract function, or don't call that divide or multiply function. Always call execute and pass the function reference there, which doesn't make any sense for a caller, because caller would expect to call this add or subtract function rather than calling execute and passing add as a reference or as a parameter to that function. So this is a kind of problem that we have to resolve. So how do you resolve this problem? To resolve this problem, we are going to use a new functionality which is called as a decorator. But to understand a decorator, we have to understand, maybe you can say, a step back called as a closure. So let us understand a closure first, and then we'll turn that closure into a decorator. Keep these two examples in your mind because the decorator is going to solve our problem, this problem here. So to understand closure, to understand decorator, we have to look at a closure. And to understand closure, let us write a simple example. Let us see what can be a scenario which can be solved by using that closure. Okay, so stay with me and see what exactly the scenario here. Rohit, you are saying while recording, so please put the video screen on your another corner, that lower right. The reason while watching the video, something Lego fully covers you in the lower right corner of this coverage. Okay, not a big deal. I'll put this right here on this one. Not a big deal. Thank you for letting me know that. Okay, so now we are in page 2, and here we are going to talk about something like a closure. So what is a closure? That's what we are going to explore. Okay. Now, first understand the requirement, and then we'll see how the closure is going to fulfill this requirement, or how the closure is going to help you to solve a kind of different problem with a simple solution. My requirement is this. I don't know whether you are aware about a language called as HTML. Actually, you don't have to precisely. This is a kind of pattern I want to generate, which looks similar to HTML. So my requirement here is something like a H1. Maybe this is a kind of a header tag, and I want to say that whatever data user is going to pass, I want to put that in this particular pattern. So something like H1, I'll say header 1, something like this, header 1, and say H1 here. Probably I'm just going to put that like header line 1, header line 2, header line 3, header line 4, so on and so forth. So this is a kind of pattern I want to generate. For H1, let's say for div, you don't have to know anything about HTML here. I just want to generate this pattern here. I want to print all these things on my console. So I'll say this is division 1, something like this, div, this div, and so on and so forth. So again, this is a pattern I want to generate, 1, 2, and 3. And just for example, again, I want to do the same thing for a paragraph P. So this is a kind of a paragraph 1. Again, I am telling you the same thing. Don't look at it as an HTML program. Just look at it as a kind of pattern I want to generate. So what I'm achieving here is, what I'm going to achieve here is like, I want to write a function in which I'll accept this header line 1, header line 2, header line 3, and I will turn it into a H1 header 1 slash H1, H1 header 2, or header line 2 and slash H1, so on and so forth. So this is what I want to try. Now, how do I do this? Probably if you look at this, the simplest way is to simply write a function like this. Maybe this is my first try. I would say something like this is my function 1, which is going to accept the data and something like a data, and probably I can say the tag as well. So for me, H1 is the tag and header line 1 is a data. Div is a tag and division 1 is kind of a data. P is a tag and paragraph 1 is a kind of a data. Very, very, very simple. So probably what we are doing here is like we are getting the input from user like tag and data, and then probably I'm going to say like something like print, and then we can use that tag here, something like this. Very simple. Again, this is where we want to put the data, and this is where again we want to put a tag. Very, very simple. So that's a one-line function. You can convert that in a lambda as well if you really want to, but that's not important here. Important thing is how we are going to solve the problem. So probably if I want to generate that output, I would say something like H1 and say this is a header line 1. So this is an example 1 which is going to generate, let's say, header 1, header 2, header 3, for example. Maybe I go for a div, that's what I said last time, and I'll say that this is going to be a division 1, precisely division 2, division 3, something like this. And this is the last one I wanted to generate, paragraph, and here I'll say paragraph 1, 2, and 3. That's it. So if you run this code, probably you will see the output which I was expecting from this application, and everything went well. Very good. I can understand that. I mean, this is a solution, and the solution is real. This is one of the solutions precisely, and the solution really works. In a sense, I was expecting this output. I'm getting this output here. So you do it in any ways, but this is one of the simplest solution, and I can get the output as per my expectation. Very, very, very simple. But I noticed something here, that when you are calling that function one, maybe if you want to generate h1 multiple times, see the problem here. Let's say right now there are only three, but let's assume that there are hundreds of lines where you want to use h1. So hundreds of time when you are calling that function, you unnecessarily will have to pass that h1 all the time. In a sense, you can say h1 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 every single time to generate the header line 1 2 3 4 up to 100. You have to do this again, div starting from 1 to 100, and so on and so forth. So though it works, but unnecessary, we are passing the same parameter to that function one all the times, which is kind of causing a maybe a frustration, because I don't want to do it. I don't want to call that function all the time with the parameter h1 or div or paragraph if I want to generate the similar data or similar lines. So how do I fix the problem? See another solution then. Maybe another quick solution I can think of is like, if I don't want to go for h1, or if I want to go for div passing it all the times, I can create, let's say, multiple functions. Probably I can say something like def, maybe I'll say this is an h1 function, which is going to accept the data. And then I can think of like print, and then maybe I can go back here and say this is going to be h1, and there we are going to use the data. Of course, it has to be f, and then we can say h1 like this. Probably this is h1. Maybe I can come back here and say this is a division. So this is div, and probably here we'll say this is div, here we'll say this is div. And again, I can come back and try to write the last piece of the puzzle, that is a kind of a paragraph, that's P. So this is going to be P, and this is going to be P. So this time my efforts are a little bit saved. In a sense, I don't have to pass two parameters. Whenever I need, I can pass only one parameter, that is the data. So probably I can pass header 1, for example, header 2, and header 3. See, my efforts are a little bit saved. So probably I can say this is going to be my division 1, division 2, and division 3, like this. And probably last example is where we can say paragraph 1, 2, and 3. So yeah, I can simply get the similar output like what I've generated earlier with a little bit of lesser effects. And this is another solution to that problem. To be precise, I think here we were calling that function multiple times and passing the same parameter all the time for h1, div, and paragraph. You see, the first parameter is exactly similar. So we looked at a kind of a scenario where we could merge those three function calls into one, like this, h1 or div and paragraph, and then we could simply say this is h1, this is a paragraph, and this is a kind of a division. So we created three different functions, and instead of passing two parameters, we came down to only one. That kind of reduced some efforts, and that looks a little bit better than the first version. But now it has its own limitations, it has its own problems. Now think about it. Today we are having only three kind of tags here, let's say h1, div, and paragraph. Now tomorrow, if you want to have something more than that, let's say tomorrow if you want to add something like a small, or something like a bold, or something like a strong, or something like, there are many actually. So if I want to add all of them, I'll have to create a separate function all the time, and that function would add the hard-coded data. Like for h1 it is going to be h1, for div it is going to be div, for paragraph it is going to be paragraph. Let's say def, maybe this is a strong, for example. So this is going to be again similar stuff. All we have to do here is like, we have to come back here and say this is a strong, and again say strong, and so on and so forth. So when you want to generate the data, when you want to generate that pattern, every single time we have to create a separate function. I hope all of you are with me and you are kind of getting the point here. The point here is, I want to generate an output something like this. To generate this output, I tried with my first function, function 1, it worked, but every time I needed to pass the same first parameter, and that's the reason I was kind of a little bit frustrated. And I tried to look at the second solution. Second solution also worked, but it has its own problem. Like now the number of functions are increased, and they are not dynamic. They're not dynamic in a sense. These are a kind of hard coded, or maybe these are the functions we need, which need to exist even before you call them to generate that output or to generate that pattern. So tomorrow, if you want to add something else, you have to come back here, you have to add the function, and then you will be able to call that function there. Okay. So probably this is something which is kind of working in one direction, but it is giving me a kind of problem in other direction. So both of them are having their own pros and cons. So this is only one function, but every time you have to add, every time you have to pass two parameters, and the first parameter is kind of repeated. This is a kind of a better solution because we are passing only one parameter, but the number of functions are getting increased every single time. So that is the problem that we need to fix right now. I mean, situations like this where we want to take help from a kind of a feature called as a closure, with which we can find a better and elegant solution to solve these kind of problems. Now, when I say these kind of problems, what do you mean by these kinds of problems? These kinds of problems means you are, in this case, look at the problem, you are generating multiple functions which are doing almost similar job. What is changed here? So if you examine these four functions, this is function h1, div, p, and something like a strong. So if you examine these four functions, you would notice that the data is common, the pattern is common. The only thing which is changing here is kind of h1, div, paragraph, and strong. So it need not to be a separate function. It can be a same function. So we tried that, and we did something like a tag and a data and tag, something like this. It worked, but it was having a kind of another limitation of passing two different parameters. So situations like this, where you want to have multiple versions which are doing the same job with a variable of a data, you can turn it into a something called as a closure, and closure might help you to solve your problem. So see the elegant solution, see the better solution of this problem. And when I show you that example, you will be able to see what exactly we have achieved here, or what exactly a little bit wrong with these two scenarios or these two solutions. So see how it can be done. Aniket, you're having a question. Why those tags in print function 32, 40, 34, 42, 46, 34, 34, 42, 42 is this one, and 46 is this one. What are you saying? Not get printed. Of course they are getting printed. You see that if you just run the code, you see that right here, h1, div, and paragraph. Of course they are getting printed, Aniket. There must be something wrong maybe in your side. So please check the code and see if they are doing the same job. Okay. Okay, so I was saying I need to find a better solution for this. To find a better solution, I'll keep that solution as it is, which is not a really kind of a solution that you should use in the real world example. So now I want to find a better one. So how do I do this? Check this out. To do this, I just see that there are four functions, function like h1, div, p, and strong. Now, all these functions are doing almost similar job. Like they are printing the data in a pattern like h1 slash h1, div slash div, p slash p, strong slash strong, so on and so forth. So what I'm going to do here is I'm going to bring all of these functions into one, like what I did here last time, and we'll write that function here, something like a function one. Pay attention again. This is function one. Now in this function, what I'm going to do is like, I know that tag is kind of changing and the data is also changing. But for one tag, you can have multiple iterations where we can change the data and we can keep the tag the same. What I'm trying to say here is, for one tag like h1, you can have multiple versions of data like header 1, header 2, header 3, and we can keep on repeating it. So what I see here is like there is one parameter which can be constant, another parameter which can be changed. So what I'm going to do here is this. Pay attention. It's very simple concept. If you understand the logic behind it, Otherwise, it is one of the most difficult concepts in Python to understand. So whichever way you want to take it, see this, the example, and probably you will understand what am I going to do here. So I'm going to turn this function into something called as outer, because now I'm going to write a outer function and inner function, and we will talk about the relationship between these two. So imagine that we have an outer function here and we have an inner function here. So this is the inner function. Now I want to use that parameter tag here, and I want to pass that parameter which is going to change for the tag inside an inner function like this. What we are going to do here is like we can move that print function inside print function in the sense the print call inside the inner function. So what have we done? We have created an outer function. We have created an inner function inside the outer. We have moved that the data to that inner function like this. And because we are in inner function, few minutes before I mentioned that inner can access all the members of outer, means inner can access the outer member outer functions tag member right here, and hopefully this might work. Now see how we can turn it into a closure. This is not a closure, by the way. So how can we turn it into a closure? To understand this again, you can easily guess that because inner is a local function, so probably I can come back here and say this is a inner function. So again, this is going to be a local inner function. You cannot access that inner outside the outer function. So I might say something like outer, and I might say something like h1. That's okay. I can say that. But I cannot just pass that, I cannot just call that inner function and say this is a header line 1, for example. So I can't say that right here. I can't say that right here because inner is not accessible outside the outer function. So now see the magic and check what exactly can be done to solve last problem in a better or in an elegant way. To do this, I'm going to come back in outer function. Pay attention again. Excuse me. So pay attention to the outer function now. So in outer function, we have declared the inner function, and now at the last line of outer function, we are again coming back in outer function. Check the spaces or check the indentation, and you will see that I'm again back in outer function. And in outer function, instead of making a call to inner, I'm going to return that inner. Now probably you can understand inner is a kind of a reference to the function which is having the body, something like this. So if I say inner return, that simply means we are returning the address of inner. And if you are returning the address of inner, this is not required. So if you are returning the address of inner as a return value of outer, I can capture it as a, for example, function is equals to outer. So in outer function, I'm returning a reference of inner function, and that reference I'm capturing in another variable called as a function. Again, think about this. Instead of inner, if I say 20, then the function would have a value is equals to 20 because I'm returning 20 there. If I return, let's say maybe a test, for example, as a string, then the function would have a value like test here. And finally, if I say something like an inner, that simply means now the function will point to inner like this. And if you don't believe me, let me just go back and say print this function and the type as well. Better, we can do it in one single way or in one single statement. This is the one, and the type is equals to, as usual, the type of function. So if you execute this code, you will see that the function here is pointing to a function which is nothing but outer dot, forget about this for a minute, outer dot inner. In a sense, it is pointing to inner function which is declared inside the outer as a local function which is located at this particular memory address. Memory address is not important. The important thing is now, can you see something? I'm able to access that inner function outside the outer function by using its a reference. It's not like I'm making a call to inner function directly, but I'm getting a reference of it outside the outer function. Now the function is pointing to inner, and this function is having a tag value of h1. Oh, what do you mean by that? Check this out. Whenever this function is pointing to maybe a reference of that inner, the inner is already storing the value of tag, which is passed as a parameter to outer function. And in this case, it is h1, which means, take a look at this. Now, because function is pointing to the inner function, which is declared inside the outer, and I know inner function is accepting a data, I'm going to come back here and say, hey, make a call to that function and pass a data. Maybe I'll say simply like a header line 1, see what happens. Now, when I make a call to that function, boom, I got h1 header line 1 h1. Oh, what has just happened? Because I called that function, the function is pointing to a inner function. That inner function is storing the data, which is nothing but in this tag variable we are having h1, and whenever you are printing the tag data tag, the tag is nothing but the h1, and it is printing h1 header line 1 h1. Okay, just give it a try one more time. So probably I'll call this function one more time, saying this is an outer. This time I'll pass some, I'm sorry, outer. I'll pass something like a div, and I'll store that in a variable called as a div, for example. And now if I want to create a division, I can say division, I'll say division 1, or maybe I can say division 2, and so on and so forth. So probably if I say run, I'm getting exactly same output that I was expecting earlier. And this time it is a way better solution than the previous one. In this condition, if you pay close attention to outer, outer is returning an inner reference, and that inner, we are able to access it outside that outer with the tag set to div, here with the tag set to h1. So this particular div or this particular function, both of them really know the value of tag. They can remember the value of tag. So when you call that inner function can print the required tag and then the required data in whatever format you are looking for. And this is the, again, similar output what we were getting earlier as well. But this is a way better function, a way better solution. The solution where we are having an outer function, where we are having an inner function, and the outer function is returning a inner function's reference or inner function itself. This scenario or this kind of a style to write a program is called as a closure. So closure in Python is a scenario where you are getting a reference of inner function outside the outer function, so that you can make a call to it, and the inner function could store or could remember the members set to that outer functions parameter, the outer functions members, all the values of that outer function members. So this is something called as a closure. I know this is a little bit difficult to understand for the first time because of there are many things out there. So what I'm going to do here is I'm going to repeat this whole scenario with a diagram. So let us see what exactly is the case. Okay, now you have seen the output, now you have seen what exactly it is. We'll try one more time. See, this will give you a kind of opportunity to see that concept with the live diagram. Okay, so pay attention. I'm going to delete this code as it is. I mean, I'm going to start writing the code one more time. Okay, so I know you are telling me that this is something that we have to repeat one more time. You don't have to tell me, because I know this is something that people generally do not understand for the first time, because it's a little bit confusing for the first time. So hopefully if you understand the diagram, you'll be able to understand all of these things here. Okay, pay attention. I'm going to repeat it one more time. See, I've deleted the entire code. We are going to write that code line by line, and I'll show you what happens in the memory when you execute that particular line. Okay, so see what exactly is the output, and what exactly is the scenario, and what exactly is the kind of logic behind it. Okay. Okay, so is closure used only before using a decorator? We'll see that in a moment. Okay, so Rohit, you will see what is the use of a closure and how we can turn that closure into decorator in the next program. First, pay attention to the closure example here. So if you want to write the closure, Forget about the closure for a minute. Just write outer and inner function. So what I'm going to do here is I'll say this is the def. This is kind of an outer function, and this is a def, and this is a kind of an inner function. So what I'm going to do here is this. This is my, I'm sorry, this is my def inner function. Very, very simple example. I'm going to say that this is print inside outer. And here I'll say print inside inner. Very, very simple example. Forget about the closure for a second. First, let us do this. I'm going to make a call to that outer, and probably you know that when I make a call to that outer, you can see the output inside the outer. Inside the outer simply means we are trying to execute the outer function. We have not touched that inner function yet. We will do that in a moment. To do this, probably I'm going to need paintbrush. So we'll see how the code is kind of generating the objects behind the scene. So whenever we are having a function like this, I'm going to come back, say that this is the function we are interested in. So let us write that function here and see what happens now. Actually, there should be one more code, but it's okay. We can add that code after this. Okay, so this is the function that we are interested in, outer and inner. You know that there is an outer, that simply means there will be a reference naturally. Maybe I can say this is the outer function right here. Let's make it a little bit on the this side so we can have some more room to add the next couple of lines of code. So this is where we are kind of saying this is my outer function, and this outer function is going to have the body, which is going to have an inner function itself. I think it's too big. First we'll write the code and then we'll come back here. So inside this outer function, we are having the body and we are having the inner function. So probably what I'm going to do here is this. Maybe I will say this is the outer function. So body, print inside outer. This is the body for that inner function. And hopefully this is going to have a reference of inner function. So let us see how it can be. So this is my outer functions object, you know, or outer functions, maybe memory location. I'm not going to add any, or should I? Okay, it's better. We can make this diagram as a complete. So better we can add the memory address as well. Let's say 10,000 as usual. For example, I'm going to make that 10,000 here, and probably I'll say that 10,000 here. Probably you know that this is going to be a little bit different address. So this is 20,000, for example, and this one here is outer. So it is a reference outer, which is pointing to that function. That's how it goes. Now, because my outer is having an inner function, internally, it is going to have one more reference. I hope you recall this diagram. I already have shown this diagram earlier as well, but nevertheless, I'm going to make it one more time. So this is the inner function I'm talking about, the inner function's reference, inner. It is going to have, let's say 30,000, for example, and this 30,000 will be right here, which is going to point to another memory object or another memory block, which will be located at 40,000, which will be a completely different box, something like this. And within this box, you will have the body of that inner function, something like this. So the body of that inner function is inside inner. So probably this is how it goes. We are having only one single line of code there. There is nothing other than this. So this is my another function, which is 0x40,000, I guess. Yes. And I'll put that 40,000 here. And then I can say that it is pointing to this particular memory location. Okay, here it is. Okay. So now you can see the scenario and you can see what exactly the memory diagram looks like. So this is a inner functions reference, which is pointing to another memory location, maybe 40,000 for our reference. So this is a kind of outer, which is pointing to inner. So understand this diagram first. Now just keep it aside for a minute, or maybe I can do it right here. And let us continue writing one code or one line of code here. So before I do it, let me run that code. I'm making a call to that outer. Outer means it is going to that outer and it is executing this function. There is only one line to execute, which is this. And because of that, it's kind of giving me an output like inside the outer. That's it. It worked. Now what I'm trying to say here is like come back and say return, let's say 100 or 200. And let us collect that return value inside a result. Watch this and try to understand this. I'm going to come back here and say result is equals to result comma, the type is equals to type of result, So run this code and probably you can see, because it is returning 200, the result will have value 200 and the type of it will be, of course, an integer. So this is pretty simple to understand. All we are saying here is return a hard-coded value 200, maybe capture that in a variable result and try to print the result along with its data type. Very simple to understand. So what I'm trying to say here is, instead of returning a hard-coded value 200, I'm going to return inner. So that's a new line I've added inside this code. So what I'm going to do now is this. I'll copy this and I'll paste it right here and say this is the next line of code which we have written here. Okay, so probably now you can understand what exactly is happening. So hopefully, oh my God, I'll have to move down every single thing. Okay, I'll do it this way. It's very simple one if you are paying attention and if you are trying to kind of getting where we are going to be in a second. So it's very simple one, provided you pay attention to the only a couple of lines of code. So probably this is a return inner. This is the code we have written here. Now, when I say return inner, what is going to happen? Let's look at this one. Result is equals to outer, which means this is the line of code which I want to execute now. Probably I should say right here. So I should say that now we want to write a line of code, or better we can do it in this way. So now we want to say something like this. The code is something like result is equals to outer. This is the code I want to execute, which means we are getting the return value of outer inside the result. Now see what has just happened. You go to outer, you execute this code, and what it is returning? It is returning inner. What is inner? Inner is having a memory address of 40,000. Means now the result, maybe I can say that this is the result somewhere here, which is having a value what inner is having inside it, which is nothing but maybe 40,000, 0x 40,000, somewhere here. Have you understood what is currently going on? This is a kind of result. This is the reference probably. And of course, it is going to have its own memory address. Let's say 50,000 somewhere in the memory. And probably you can see that it is pointing to, again, the same memory block somewhere here, because this is 40,000 and this entire block is having an address of 40,000. That's it. This is what is just getting done behind the scene. That's it. You need to just understand only one thing, that the result is equals to outer, and probably that result is equals to outer means the result is pointing to the inner function, which is actually the memory address of 40,000. This memory address happens to be the inner function's body. So now tell me, if I run this code, what will be the output? The output will tell me like the result is pointing to a function called as the inner. So result is pointing to the function called as the inner, because that's a body of function inner. And probably the type of that function or the type of result has to be a function, because it is pointing to a function here, So that's how it goes. So basically, when you're talking about the example here, all we are saying is like both the inner inside this and result outside that outer, both of them are pointing to the same memory block. This is a perfect example of function alias. To be very precise and to be very honest, this is exactly what we have discussed earlier with simply saying, hey, this is a function alias. Exactly what we have said last time, function alias, So if you know function alias, I hope this is not very difficult for you to understand the case, what exactly is happening, I know it's very simple, but it's a little bit complicated because of the hierarchy, So in this case, now you are having this result object, which is pointing to this particular memory block, So this is called as a closure. This result object is called as a closure. Okay, very good. I see a positive response from your side. That means you have understood the concept here. And if you understand this concept, believe me guys, you can easily understand the decorator. And if you understand decorator, you can easily understand the flask. Now flask depends on decorator, decorator depends on closure, closure depends on something like outer inner, and it also depends on the function alias. I hope we have spent enough time talking about the function alias. You now have the memory representation. How does it look like? And if you know this, probably it'll be pretty much simple to understand next couple of concepts. So let us see what exactly is coming now. So now this is called as a closure object, or simply you can call it as a closure. Now, why it is a closure, or what exactly do you mean by a closure, and what is an advantage of it? Pay attention to this now. That is going to be really important. I should have made this arrangement, but it's okay. I can do it here. See this. Now what I'm going to do here is this. Okay. I'll modify this code a little bit. So I'll say that the outer right now is not accepting any parameter. That's okay with me. But now I want to accept a parameter. Let's say the parameter is something like a num. I don't exactly mean to use that parameter anywhere, but I'm just passing that variable here. Okay, so now we are having that parameter here num, and if of course I'll have to pass that parameter value here, something like a 10 or 20, whatever it is. So what is going to happen now is this. If I want to use this parameter inside that function, so first forget about the closure and tell me, can I access that num parameter here? So can I say something like num is equals to num and say the type is equals to something like the type of num? Of course, yes. Why yes? The reason is very simple. We already have looked at the rule saying inner function can access all the members of outer function. We already have said that many a times earlier. So with that rule, I can easily say that, yes, it is possible for me to access that num inside the inner function. Okay. So now see what is the magic behind that closure and why closure is very important. I'm going to modify my code a little bit here. So I'm going to remove this part here and we'll write the updated code. So guys, just stay with me. There's only a couple of steps left to look at the actual closure object, Okay, so what I'm going to do here is this. I'll just move it a little bit further, and probably I don't need this arrow for a minute. I'm just going to make this. I'm making a kind of a room here. That's it. So that it will be easy for us to see what exactly is coming and how exactly we can fix that problem. Okay, so this is a kind of memory representation of function one, or maybe outer function. We can call it as an outer function one, whatever it is. And actually this is pointing, outer is pointing to this particular memory block. That's what we already have discussed earlier. Okay, so now because we are passing that num, see what we are trying to say here internally, so this print is always there. There's no second thought of that. Print will be always there, but along with this, the one which is kind of hidden, and that's the reason it's a little bit confusing for the first time, which is hidden is the local member or the input parameter num. So do you notice something? If I call that function, it is going to create a variable internally, and when I say internally, that simply means there will be a variable, and as you pass the parameter value of that num, for example 10, that num 10 will be added or will be kept inside this memory. So now I'll have to change this call a little bit, and we'll have to say something like this. Watch what happens. So probably I'm going to say here outer is equals to 10. So probably I'll just copy this as it is, and we'll say that this is now the function call. We are passing 10 value here. And because we are passing value 10 to the outer function, you can easily guess that the 10 will be the parameter value of num. So it is a value of parameter num. That simply means I'll just make that room saying 10 num is equals to 10. And this is what I'm going to put right inside this block, right inside of this block. This is a kind of hidden, and that's the reason why people generally get confused. So the num's value is 10, and that num's value 10 will be added inside this function block, because this is the outer function and num is inner parameter, or sorry, num is the input parameter of that function. Now, because num is 10, you can easily guess if I try to print that num's value here. Now, I don't think we need a second thought on that. So probably I'll just delete that block here and we'll update it with my inner functions code. I'll say that this is the code which is there inside the inner function. Somewhere here, it's too big to write the code. So probably I'll just make it a little bit smaller. And let me just split that across multiple lines so it will be easy for me to put that in one block like this. And now if you try to pay close attention to what has just happened, you would easily understand that within this block, can you see and can you tell me, like if I'm trying to print that num within this block, this is nothing but my inner function. Can you tell me, like if I'm trying to say something like, hey, print the nums value here, can you just tell me what is the nums value here in this particular object, in this particular scenario? What is the nums value? Of course it is 10, because when you say num here, it is going to refer the num from, not here, but it is going to refer the num from this particular context. And that is the most important thing that you need to understand. That's it. This is the way to do it. So one more time, the way we are going to refer this num is like this, you know. So this is the num. Probably I can say somewhere here, or maybe I can say somewhere here, whatever you can say. So this is the num, and I'll say that this num here is kind of getting referred from this particular memory location. So this num is nothing but 10, and that is the reason no matter how many times inner is getting called, you always will get num's value as 10. Guess what? I'm going to call this a result multiple times. Say a result, result multiple times like this, and you would notice every time you are going to get inside inner num's value is 10, num's value is 10, num's value is 10. It's pretty much a simple way to represent the scenario with the help of diagram, and this is what is happening right now. Because I passed the 10, the object, the function object which is getting called, which is getting created behind the scene, has already mentioned that, hey, this is num's value, which is 10 here, and that 10 is getting accessed inside your inner function all the time. No matter how many times inner function is getting called, it always will refer to the num, and that num is going to have the value 10. That's it. This is what we are kind of looking at a particular scenario. And if you look at this scenario, the scenario here is called as a closure. So closure, think about it as a kind of a feature with which we can create a outer functions object, and we can keep the we can keep the local members of that outer function and then access them inside the inner function. This is called as a closure object, or simply it's called as a closure. Adesh, simultaneously we are calling to outer function and returning the inner function reference as well in one line. Of course, that's what we are doing here. So outer function is going to have those two lines. This is the first line of outer function. This is the second line of outer function. These two lines are inner functions body. So we don't care about this one. So this part will come inside the inner function. In outer function, there are only two lines. This one, which is going to say print out inside outer, and it is going to return the address of inner function. So that's how it is. Okay. Utpal, repeat. What do you want me to repeat, Utpal? Just tell me precisely. I'll do it one more time if you really want to. Ketan, your question, after returning inner, will it create a separate variable inside the inner, or just will use the outer num? Of course not. It is not going to create a separate variable num. It's going to say that num which is referred in an outer variable. Okay. So that's how it is. It's not going to create a separate variable there. Utpal, definition of a closure once again. Forget about definition. Definition, there are many ways you can define it. I mean, depending on which website you refer and which documentation you look at, there are many different versions of that closure. People say closure is nothing but a scenario where you are having an outer function returning inner functions reference. Maybe another website might say a closure is the way to hold the reference of outer functions, local members, and access them in an inner function. Definition can be in anything. Need to understand the concept. So concept is the way you are writing the code here will create a function object where you are having the local member set to 10, which we can access it in a num variable and then do the job. Okay. So hopefully this is the way you can do it. Who's that? Parag. So is it mandatory that we should not return anything from the inner function? It's up to you whether you want to return it or not. It's up to you. So probably if you want to return something, you can, but it's not mandatory. I mean, what do you want to do inside inner function? It's up to you. But what is what needs to be done from outer is kind of mandatory. There we have to, just return inner functions reference. This is mandatory. This you can control. If you want to return something, it's up to you. So whether to return something from inner or not, you decide. But returning inner functions reference from outer is mandatory. So that is how the closure object can be created. Okay, Vipin, can we modify the value within the inner? No, you can't. I mean, value of num, you can't, because you know that even if you modify a value, it is going to create a local member of that function. It will never allow you to create, never allow you to modify the read-only parameter value. So num is kind of read-only. In a sense, you can't use or you can't modify that. That's a input parameter here. And it is not meant to be modified. It's meant to remember the value of num, okay? So precisely in closure, the inner function remembers the value of outer functions parameter. That is the concept that you need to understand. Omkar, is it same like prototype in JS? Absolutely not. Sorry, it's my bad. Not exactly, but you are on the similar line. But by the way, Omkar, if you know JS, then JS also has this functionality called as a closure there. So closure there is also possible. And yes, you can write almost a similar code except couple of syntactical changes, and you can run that code in JS as well. So JS goes on a similar lines. But it's not exact like a prototype. Prototype is having a little bit difference. You are on a similar line, but it's not exactly the prototype. Prototype there in JavaScript is the way you can share the data amongst multiple functions, where I mean, in other cases or in other languages, you can do it with something called as inheritance. That can be done in JavaScript by using prototyping. Okay, that's a kind of similarity if you're looking for. Okay, Rishikesh, your question. For calling inner function, we need to call inner function naturally. To call inner function, we need to make a call to that. Absolutely. Outer function calling only the outer and the inner address. Exactly. Outer function is executing its own body and then returning the inner function's reference. That's it. Other than that, outer function is doing nothing. Okay. Rohit, can we say we are calling the inner function globally or by creating the alias? Absolutely right. To be very precise, Rohit, what you put there in one line is kind of describing the importance or the usage of closure. So closure will make you use that inner function outside the outer function. Have you noticed something? I said that last time that you cannot call the inner function outside the outer function. But with the help of this closure, you are making a call to that inner function outside the outer function. Of course, not directly, but something with something sort of that is happening here. So basically, with the help of closure, you can access the inner function outside of outer function. And not only this, there is an advantage here that it can remember the value which we already have set inside the outer function. That is an added advantage of closure. So Jagrat, your question, but it will not create a separate variable, then how will it use the num value? Scope of outer function is finished, its scope variable will also finish. Very good. Now, probably if you can understand, Jagrat, probably you're absolutely right. I mean, if you are losing the scope of outer function, how is it possible for you to remember the value of value of the input members, or how is it possible for you to remember the value of num in this context? So how do you do that? To be honest with you, again, when you are calling that function something like outer, the outer starts here and the outer ends here. Probably right on this particular line, the outer function finishes its scope. There is nothing left in this. But now, I mean, you are in Python, and I don't know whether you can recall this or not. I mean, though I said it is not going to repeat or it's not going to copy, but though if you can recall something, I said that in earlier as well. Whenever you are kind of using a global variable inside the local variable, it creates a copy of it and then it's tried to use it. So though I said that it remembers the value of num, precisely behind the scene, it is going to create a copy of it and then it is going to start using it. So it remembers it, at the same time it uses the same value num internally inside this function. How does it work with this? It does that because still the function, I mean, you lost the scope here, but still the reference is alive. And because the reference is alive, Python is not going to Python is not going to let go that reference there, or will not let go this object here. So though it uses the value of num inside it, it is going to make a copy of it and then it will use it here. Of course, there is another keyword, something also no local, that can be used for avoiding this memory copying. We'll talk about that later. But right now, the concept here is, though you are losing the you are losing the scope at this particular line on line number 13, still you are holding the reference of it. Because you are holding the reference of it, Python will not let go that it will not let go that object which is created here. So it will keep that object alive in the memory till you are done with this particular reference. Later in point, maybe whenever Python finds out that there is no reference left to this particular memory object, it is going to delete this and this either. So though you are losing the scope, still the object will be alive in memory, and that's the reason, Jagrat, it is possible for us to access the members or access the entire data for the inner function. So this is a kind of a case where you are having outer and inner in one single scope. Because you are having an inner function has to have a reference of outer function, and that's how it does the job. Okay. Utpal, are you going to show any example of closure in the practical scenario? I showed one of them earlier where we were using a kind of a pattern generation, and the pattern generation is going to use this a kind of, the closure. I'll give you a couple of more examples, and decorator is the best example of a closure. Nothing other than decorator can explain usage of closure better than anything, So just wait for a minute. We'll talk about the decorator in a minute, but before that, you can understand how it works. Okay. Probably who's that? Vipin, where to use closure in the real world? Just wait for a minute, Vipin. You will see that in a minute. Okay. Okay, so now you know what that closure looks like and how you can use it. Let me write the code again. Now this time, if I write that code, probably you can easily understand that, maybe instead of me writing it, you can write it on your own and see if it is possible for you to finish that same example we started last time. The pattern generation, where I wanted to create the HTML-like pattern. So probably I was thinking like this. I want to create maybe a function like a tag, for example. I'll pass the tag here as a parameter, something like this. It doesn't make any sense to have this one. So maybe I'll say create a tag better, and we'll pass a tag here. That makes a lot of sense. And then we can have a inner function, def, I'll say inner. It doesn't matter. I'm sorry. It doesn't matter actually what you are writing that function name, because this function name is not visible to outside world. So you can say inner, you can say whatever it is. I don't care. Generate pattern or whatever it is. So this is the inner. The inner is going to have a data. So now the data will be passed to the inner, and the tag will be passed to the create a tag function. Here in the inner function, I'm going to print this tag, something like in this fashion. This is the tag. Again, I'm sorry. My bad. It's the way we are going to do it in this thing. Then there is a data in between, sorry. And then again, slash, this is the tag. Okay, that's it. Very important, we'll have to return inner reference. Don't make a call, return inner reference. Now, hopefully you can easily write down that pattern. Probably I can say h1 is equals to create a tag h1. Maybe div, which is equals to create a tag div. Again, what's that? P, for example, which is equals to create a tag P, and so on and so forth. So probably this is how it goes. And now if you are having those references, h1 is pointing to a function where the tag value is h1. So probably you can call that h1 and say this is the header line 1, Maybe we can just write it a couple of times, header line 1, header line 2, header line 3. Similarly, div, maybe I'll say division line 1 or division 1, 2, 3, for example. Again, that's the paragraph. So paragraph 1, 2, 3, and so on and so forth. If you notice something, we are getting exactly same output that we already have generated twice earlier. So probably in the first iteration, it was good, but we were passing multiple, we were calling that function multiple time, passing the same parameter as the first parameter every time. We avoided that. What the hell? Who's that? Oh, I'm sorry. It's my iPad. Okay, sorry. Siri was talking something nonsense. You know? Okay, so here it is. So in the second example, we try to club all these functions into one. I'm sorry. We try to split that one function into multiple function, and then we saw a kind of limitation. The limitation is like, see, in this case, we were doing the right job, but we were having multiple functions for doing the same job. Here it's a combination of both of, it's a best of both the worlds. So probably here we are having only one function, but still you are calling that h1 multiple times by passing only one parameter. So it's best of both worlds. So now if I run my code, I see that this is h1. I can see that right here. Parag, if you want to see h2, h3, h4, all we have to do now, we don't have to create any separate function for that. Call this function and pass h2. If you want to go for h3, I can say create a tag h3. That can be done only once. And probably you can say something like h1, h2, and h3. So probably right here, you can say h2, h2, h2. Again, h3, h3, h3. You see, I'm now able to generate the things dynamically. In a sense, I don't need to create a separate function for the h2, h3, and so on and so forth. So this is how it is kind of doing the job. So probably this is the way you are kind of generating the pattern by using something called as a closure. Important thing is not to generate the generate the pattern. Important thing is to understand the closure object. So this here is called as a closure. So this is the way we can do it. Okay, Aniket, try that on your machine. You can also debug on your machine and see how it is going to do the job. I already have explained it from the memory point of view. From the diagram point of view, it's kind of accessing the variables value from this particular memory block. Okay, this is the outer memory block, or you can say the outer memory object. So this is how it is going to do the job. Okay, so Akshata, your question. But in all the cases, a separate copy is created in every call of a create tag. Leave it. I don't care about whether it's creating a separate copy or not. For me, I'm talking to Python. Let Python decide how it wants to implement internally, whether it wants to create a copy of it, whether it wants to create a reference of it, or whether it wants to do anything other than that. We really are not bothered about that. See, ultimately, when you are using a language, then we have to use those features language is providing me. It's not like I can jump into the language. I can actually, it's not a big deal, but I think it's not necessary. Otherwise, you are going to make your life very difficult for yourself. So if Python is saying, use this feature and it will work for you, you don't worry about how it is getting implemented behind the scene. To be very honest with you, the Python compiler is written in C. I hope you can recall. We talked about this on day one. We said that this is something called as a C Python. So if you really want to understand that, you have to go to the pointer to pointer to pointer basic, and then you will see how it is getting implemented. But being a Python developer, we don't have to go in that details, at least at this level. If you are having a little bit experience of Python, then you can try to look into it by literally copying or literally downloading the Python code, and then literally looking at it from the code perspective. Fine, I agree with you, but not at the beginner level. Otherwise, you'll make your life a little bit complicated to understand. So if Python is saying something is going to be done, it will get done. I don't care like how it is doing it, at least at this point. Okay. So Akshata, yes, it is going to do it, but we are not bothered about that. Let it take its own decision. We will use Python, not the language in which Python is written. Okay. So that's how we have to understand that. And guys, it's not like this only closure point of view I'm talking about. I'm just talking about in general. I mean, it's good to know the internals, but you can learn the internals if you are having a command over that language. If you know the language very well, user's point of view, then you can see, hey, how it is doing it internally. Makes sense. Okay. Anyways, I'm trying to give you best of both worlds again. You are kind of a beginner to Python. At the same time, I'm telling you like what happens behind the scene that will make many things clear. And I know knowing internals will make the things clear, but at the same time, knowing internal will little bit confuse you at the beginning level as well. That's the reason why I'm restricting myself to a certain level, because after, if I cross that level, it will start bouncing on your head and probably you will get a little bit confused. Rather than it will simplify your scenario, it will make it complicated to understand. That's the reason I'm just giving you a kind of overview of it. Okay. Aniket, thank you. Okay, fine. Actually, I was on mobile, so just ask. Okay, no problem. If you have already understood it, probably you must have understood it from the diagram itself. I know what you're talking about. You wanted to see whether the address goes and how it is doing it, but from the diagram itself, the things are pretty much clear. Okay. Adesh, is there any shortcut to calling H1 def be single line than multiple lines we are getting in multiple times? There is no shortcut. I mean, precisely Python has already shortened your life so much that in hardly a couple of lines, you are achieving too many things. So other than that, there is no shortcut, you know, you have to write some piece of code there. So probably other than, I mean, after this level, there is no shortcut. This is the final level, you know, so that's how it goes. Okay. Jokes apart, what we have seen here is like a way you can remember the outer function's value inside the inner function and still call the inner function multiple times to get the job done. Very, very simple way to do it. Okay. Now, coming back to one more example, see if you can understand that. It's very simple example, by the way. This is again a closure, by the way. So what I want to generate here is a number table. So probably if I want to generate a number table, let's say 2's number table, 3's number table, 4's number table, then probably I can write in different ways. I want to do that in terms of something like a closure, a number table, simple number table. So probably what we want to start here is like, I want to start a function and say, create a table of a number, for example. So the number here is 2, 3, 4, 5, and you can pass anything there and you are going to get a number table of that number. So 2 1s are 2, 2 2s are 4, and so on and so forth. So we can generate that up to 10, for example. So probably I'm going to say that this is a inner function here very quickly. I know we want to go from 1 to 10. So I want to say the count, which is equals to 10 to start with. If you want, you can change it to 20 and you get the number table starting from 2 1s are 2, 2 20s are 40, something like this. So you decide how you want to go there. But I'm going to start with count equals to 10. Now, how do you get it done? The logic you want to implement here, it's up to you. That's not important. Important thing is the structure. So again, I'm going to say here, see, I want to generate a number table. So probably I can say a table which is equals to, I hope you can understand, this is a kind of a list comprehension I'm using here, which is going to give me a kind of number star index, where index is in the range of count plus 1. I hope you can understand what am I writing there. So probably it is giving me the number table, which is going to multiply the outer number into the index values here, not necessary to have the spaces in between. So number into index, and index will start from a 0 to count plus 1. Actually, we don't want to start with 0. It's better we can start with 1. That will give us a clear-cut idea, like 2 1s are 2, 2 2s are 2 2s are 4, 2 3s are 3, 2 2s are 6, 2 3s are 6, and so on and so forth, up to 2 10s are 20, something like this. So now we can come back here and say return inner as usual. This is the closure we talked about. Now I'll say number table of 2, which is equals to create a table, sorry, not create tag, create a table of number 2. And you just have to need to go for calling that function, print, the number 2, and just make a call to it, because we are just calling that inner function where the count is equals to 10. Of course, we need to print that table somewhere. So I'm going to print it here. And when I say run, probably you will get the 2's number table. So 2 2 2s are 2, 2 3s are 2 2s are 4, 2 2 2 3s are 6, and so on and so forth, up to 2 10s are something like 20. So something like this. So probably when you talk about something like this is your logic. Maybe if you don't want to go for this, you can run a simple for loop and say for something like index in range of 1 count plus 1. Then you can say print, and you can keep on printing it right there. So probably I can say the number, or maybe we can directly print it here. This is the number star index. So how you want to generate it, it's up to you. You decide. But The structure is this. So now we are getting the twos number table here. If you really want to print a number table in a better way, so probably you can do it in this way and say this is a number into the index, which is equals to this. So 2 ones are 2, 2 twos are 4, 2 threes are 6, 2 fours are 8, and so on and so forth. So that's how we can generate it. Okay. Okay, so now I think you must have got a clear idea like how we can do it. Probably if I want to generate the number 4 or number 5, let's generate a number 5 in this case. All we are going to say here is, hey, I want to create the table, the number table of 5. So maybe I'm just going to make a call to this function, and hopefully I'll get the 5's table. 5 ones are 5, 5 twos are 10, 5 threes are 15, and so on and so forth, up to 5 tens are 50. That's it, very simple. Now tomorrow, if you decide to go for maybe not, you don't want to stop at 10, you want to go for 20 numbers in that table. So we can pass the count is equals to 20, and guess what? You will get again 5 11s are 55, 5 12s are 60, 5 30s are 65, and so on and so forth, up to 5 20s are 100. So that's how it can be done. Okay. So again, what you write here is not important. What you are writing as a structure is what is important for me at least in this example. And this one here is called as a closure. Tanya, I think it's better you can look at the video where we have already recorded the list comprehension, because it's a little bit longer to, I mean, it will take long time to discuss all that concepts again. Okay, so I would request you to look at the video and understand the list comprehension. If you find any problem, of course, put that message on WhatsApp. I'll try to answer it there. Okay. But again, it's not necessary to use a list comprehension. You can use anything there. It's as simple as that. Okay, so now you know what exactly is a kind of a closure looks like. Now we'll try looking at the previous example we have seen in this context. Remember, this is the problem we were facing earlier. So again, going back where we have started, where we began today, we started with that outer inner. We took this example and we converted that into a closure. We understood the closure now. Now we are going to look at the second problem we were facing earlier. We were having those two functions, add, subtract, and we were using that execute function. And it was kind of working last time, but every time I needed to use an execute function, you know. So we wanted to solve this problem by using something called as a decorator. But what do you mean by decorator? How does it work? That's what I'm going to show you right now. Please pay attention. Before we go for decorator, first confirm, most of you or all of you if possible, whether have you understood this closure part thoroughly or not. Have you? Okay. Because the very first statement I'm going to make here is a decorator is a closure. So basically a closure can be converted into a decorator. So precisely if you want to write a decorator, you have to first write a closure, and that closure will be converted into a decorator. And believe me, decorator is even simpler than closure. And if you have understood the closure, you will understand decorator, because it's just one line of code. That's it. It will convert your closure into decorator and it will make your life so simple. Okay, we'll see this. Utpal, I know you need to revise it and practice it a little bit more than what we have seen here to understand this completely. But on a high level, I hope if you have understood the concept, things will be simple for you to revise and practice when you do it on your own. Okay. Okay, being said that, let's continue with the next page, page 4, I guess, and there we will start with the decorator concept. Forget about decorator for a minute. First, let me come back and try to look at the same scenario what we have said last time. This time I'm going to save mine and your time by simply copy pasting the code. That's add and subtract I was talking about, execute I talked about, and this was something with which we could simply use that the decoration there, you know. So this is what we have decided last time. Now, if you pay a little bit closer attention to this execute function, I think it's better we can arrange it in this way. So it will be easy for you to focus on add and subtract and not on execute, because execute has to be done only once. All the time you are going to write your own functions like add, subtract, multiply, something like this. So this is a kind of a function that we are trying to call here, you know. So what we are going to do here is this. Pay attention. Earlier, when I wanted to decorate my result, I was doing something like this. I was calling that execute function and passing add. I was calling that execute function and passing subtract. This is something which I was doing earlier. So probably if I run my code, I was getting, of course, the proper decorated result, and yeah, that was working fine. But if you see the problem, I'm calling the execute all the time. And when I'm saying I'm calling execute all the time, this is not a good sign, you know? So the caller would need to really call the add and subtract and not the execute. But with this limitation that we have to call execute all the time, a caller has no option but to call that execute and pass add as a reference, call that execute function and pass subtract as a reference. Though it works, but it's not an elegant solution, you know that. So we need to find an elegant solution now. Okay, so see how it can be done. Now you know what closure is. I am going to come back here and precisely convert this execute into a kind of a closure. Or maybe I'll say that this is kind of execute function now going to turn itself into a closure. Okay, so see how it can be done. Yeah, of course, calling an extra function. Actually, we are unnecessarily calling an extra function to call the original function. So this is a kind of an effort. We are going to see how we can turn this execute function into a kind of a decorator. So before that, let's see how it can be done here. So what I'm trying to say here is like execute. Forget about decorator again. I'm just trying to make the things clear with the closure first. So this is an execute function. I want to turn it into a kind of a closure. So how do we do that? To do this, I'm going to say that the function is where we are going to take a reference of add, something like this. And when the function add needs to get called, I'll put this in an inner function like this. So all these statements where we are making a call to that function, passing the parameters like 20, 10, so on and so forth, will move every single thing into inner. You know, if you want to convert anything into closure, it's mandatory for me to return reference of inner function as a return type of outer or return value of outer function. So the very last statement of outer function must be return inner. Okay, so see where we are going now. Okay, so now if I look at the scenario, when I call execute, you know that execute function will get called. It is really going to do nothing, but it will keep the reference of function to add. In a sense, for line number 20, when that memory will be allocated, in that memory, the function will point to something like add. Or for line number 21, when the function will get called, probably you will see the function will point to subtract. So that's what you need to remember. Okay. So if I run my code now, pay attention. If I run my code now, you will see no output because execute is not going to call my inner function. If you really want to call my inner function, then you have to store that address somewhere. Maybe I can say this is a reference to add, and then we can call that ref add function here. Or this is a kind of reference to subtract, and then we can call that ref subtract here to see the actual output. So I'm started getting the actual output, but now it is a little bit extra effort that we have to call the function which that return value is pointing to. So when I say ref add, the ref add is going to point to inner function where the function will point to the add function. So function is a parameter here. It is going to point to the add function. And whenever I make a call to that inner by saying ref add parenthesis, I hope you see we are making a call to that by passing 10, 20 and 10 as hard-coded parameters, and things are kind of working there. You know, so things are kind of working, things are kind of giving me the decorations there. Now, if you see this, let me just come back here and say, hey, I want to call, rather, I want to get the multiplication of two numbers. So why am I writing it? It's simplify. I mean, I can simply copy and paste it and say, this is going to be, I'm sorry, multiply. And this is how we want to do it. As simple as that. Now, if I want to get the multiplication result, again, I'm going to say ref multiply, which is equals to execute and say multiply. That's the function name. And then you can call the ref multiply in order to get the multiplication result with necessary decorations turned on. So this is how we can turn that execute function into a kind of a closure. That's it. This is the way we can do it. So now you must be wondering, what have you done? Last time, at least it was kind of bearable, like you were calling that single function execute and it was working. At least only one function needed to call. But this time, can you see the problem? The problem is you are not only calling the execute, but also you are calling the ref add. I mean, it's returning the inner functions reference, and you are also calling that inner function as well. So now you have added one extra line of code. What have you achieved? Are you kidding? I mean, you wanted to solve that problem. You already have increased the efforts. What are you doing? So if you're thinking on the similar line, you are absolutely right. Exactly. So it's kind of unnecessary to write this code, and you might understand, you might say that this entire kind of execution, this entire kind of program is useless because it, instead of solving the problem, it has increased the problem's complexity. I mean, every time I need to call that function, get the reference, and again call that reference, and it has screwed my life. I mean, if there are hundreds of functions, I need to do it every single time like this. So guys, now a little bit secret here. I know I've increased a little bit effort here and you are doing it with this particular code, but now the magic here is you don't have to do it. Okay, you don't have to do it. Why? See the magic, see the Python's magic. You are going to call that original function back. You say this is add, for example. You don't need to call the parameters, but still I'm going to pass the parameters, let's say 30 and 20, for example. I'm going to call that subtract function, pass parameters like 40 and 50. See what I'm doing? I'm not going to call that execute function. I'm going to call the original functions by saying something like multiply 50 and 60. I'm going to call the original functions, not the execute function anymore. Why? Because I think this is kind of not necessary, because it's kind of forcing me to call two functions. Naturally, just calling these two functions, calling these functions will return nothing. I mean, it will not print anything. That's the reason you are not able to see anything on the line here, or you're not able to see anything in the console. So probably it's okay. I can understand that. Now, I want my decorated result back, So I want my decorated result back. And for that reason, what I want to do here, or what I'm going to do right now, is whatever execute function I turned that into a closure, I want to get it called automatically. So this is the call that I want to call in order to get the decorated result for addition, for subtraction, and for multiplication. I already have shown you these examples. Like if you call, or if you write the code like this, execute add, reference add, and make a call to it, you will be able to get the decorated result of addition. If you do it, you will get the decorated result of subtraction. If you do this, you will get the decorated result of multiplication. Things were working earlier. But all I'm saying here is, if you don't want to do it on yourself, I mean on your own, and you should not rather, because you are in Python, and in Python, there are many different ways you can simplify your life. So Python says, don't do that. Let me do it for you. Let me take the hard part. You just do it only once, write this closure, and just forget about it. If you want that add, subtract, and multiply to call this execute function automatically, all we have to do here is just go on the declaration of add, just before the declaration of add, and say, hey, before you call add, I want you to call an execute function. That's it. Watch what happens. I am not going to call that execute function at all, like what I was doing earlier. I'm going to make a call to my original function add, and then see the magic. So I have Harry Potter's magic wand. I'm going to turn it on and see what happens. 1, 2, 3. Let me just run this code, and oh, my bad. Oh, it is saying like inner function is taking two positional parameters, but two were given. Oh, you see that here it is calling that ref function. We are passing a parameter of 30 and 20, and that's the reason why it is complaining, hey, don't pass the parameters here 30 and 20, because my inner function is not taking parameters. No big deal. It's very simple to fix. P1 and P2, and instead of hard coding the value of P1 and 20 and 10, I'm going to pass that P1 and P2. So what is happening here is this: internally, this particular call is going to call, it's going to get that execute function called automatically, which will return inner functions reference, and the parameters which you are passing here will be passed to the ref function. So if I run my code with the magic wand, you see, oh, it's calling that decorated result by doing nothing other than calling the original function. Watch what happens. For subtract and for multiply, nothing happened, because the subtract and multiply, they are not printing anything within their own functions. They are literally returning the value. I want that execute function to be called for subtract automatically. How do I do this? I mean, if I want to do it manually, I could do that. I mean, I could say something like this, you know, that subtract function, I can pass what? 40 and 50, sorry, 40 and 50 like this. And probably I'll get the answer that -10. Yes, I can do it for subtract, but I don't want to use that execute function at all. All I'm saying here is, hey, Python, do that hard work for me. I just want to call my original function exactly like this. Coming back here and say, hey, call this execute function. I don't care how and when you are going to call, just make sure that you're calling the execute function, and still, you see, you are achieving the same job here. If you don't believe me, multiply is not doing anything right now. Just go ahead and say something like an execute here. And yes, it is going to do the job for you. See, the multiplication is also working. So behind the scene, if you again put a print statement here and say inside execute, inside execute, and if I look at the function here, which is equals to, you know, the function, and if I try to look at the type of that function, you will notice that automatically behind the scene, Python is going to call that function. See, inside execute, Python is going to call that function with add, subtract, and multiply, as if I was doing that, writing these 2 lines of code every time. I hope you are not getting it. I know it's a little bit difficult to understand for the first time, but those who are coming from Java, they can easily understand because they already have seen something similar called as annotation. Exactly. Who's that? Preeti, absolutely. So probably if you are coming from Java, you can see this is the annotation, and this is exactly similar lines Java's annotation work in Java world. So yeah, this is kind of a kind of annotation there, but it's more than that. I know, Prerna, it's a bouncer for you, and not only for you. In fact, there are many people who for whom this is a kind of a bouncer, and that's the reason I'm going to do it one more time. So Prerna and with the others, can we try this one more time? I mean, I've just shown you that example, you know the output, but now we will try again, like what I just showed you in case of closure, you know. So what we want to do now is, like, I'm going to delete this and I'm going to start doing it one more time, you know. So hopefully that will give you a chance to understand what is going right now. Okay, so let's see this. I'll keep that example for you as it is. I'm not going to bother about that. So I'll create a separate page for this example. And this is page 5, for example, here. I'm going to start with a very simple example. Let's say I want to just say add 2 numbers, you know, very simple example. It's not necessary that you have to go for add, but add is simply, I mean, it's a simple way to explain the things. That's the reason I generally take example of addition, multiplication, or subtraction. We'll write some more complex examples after we are done with this. So, excuse me, what I'm going to do here is like def, this is my add, this is P1 and this is P2. And all I'm saying here is just get the addition done. As simple as this, by saying something like addition, which is equals to, say, P1 plus P2. Now, please pay attention and see if you can understand this. This is 10 and 20. And what it does is, like, it just calls that function and tells me the addition of 10 and 20 is 30. As simple as that. Now, probably I want to get the result maybe enclosed in dashes. This is what I was thinking about last time. This time we'll be enclosing it with stars. So star, 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 star. addition 30 and star 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 star, something like this. I want to do it one more time. See, if I want to do it, all we have to do it here is this. Maybe I can come back and say print. This is the star. I'm going to print it, let's say 40 times, do it after the call, and we'll get the decorated result like this. Decoration does not mean the actual decoration like this. Decoration can be thought of anything. We'll talk about that later with the help of a real example of logger. But for till that, just understand decoration means you're modifying your result. How you want to modify it depends on the functionality, but to start with it, this is the way we can do it, you know. Now, when you talk about the kind of example here, I modified my original code and there I started adding the decoration there. I mean, for me, yes, it worked, but for that, you know, I just had to add that particular lines of code like print star and line number 2 and print star and line number 4. Now, there are a number of occasions where I need to do something similar. Let's say there is a function like subtract, there is some function like addition, divide, or there's a function like multiply where I want to take the same approach. So is it possible for me to do that in a kind of a fashion where I can reuse my code? That's what I'm thinking about here. If I'm thinking about that, then I think it's not a good idea to write this code in every single function. So let me delete that. And now I'm thinking about to turn this into a kind of a reusable code or reusable solution. To make it reusable, we thought of creating another function. Maybe this time I'm going to call something like a decorate result. Better. I mean, we have called that execute many a times. Let's change the name right now. So I'll say decorate result. And in this decorate result, we'll take a function as a parameter. And then here we can do that job by printing it 40 times, for example, like this. And in between these two, we'll make a call to that function and we'll pass necessary parameters. Let's say 10 and 20, something like this. So the 10 and 20 parameters are going inside this function and probably, or maybe we can take that parameter as an input, P1 and P2. And instead of hard coding the 10 and 20, we can say P1 and P2. So in this case, see, I'm not still getting those stars back because we are still calling the original function. Now, if you want to get those stars, probably it's not the original function that you need to call. It's the decorate result function that you have to invoke. So how do you do that? You do it by changing the function name to decorate result and passing the first parameter as the function that you want to call with P1 and P2, that P1 and P2, which will be passed as input parameters to that function, which means now it is going to call the decorate result. The function here will point to add. P1 and P2 will point to 10 and 20. And then you can say the function getting called on line number 3 will be the add, and we'll pass the 10 and 20 and we'll get the addition done with the help of decoration, whatever decoration we have thought of here. Just quickly, as quickly as possible, let me debug this code, and probably when I call that function decorate result, see what happens here. Here function is pointing to add. So if you hover your mouse for a second or two, you see that this function is pointing to add, and P1 and P2, both of them are 10 and 20. So which simply means I'll put a breakpoint in add as well. So if I come back here and say, hey, just call that function, you see the function is the function add is getting called, and we are printing the addition of 10 and 20, as simple as that. And then we are printing the actual output. And then finally, sorry, it's not needed right now. So finally, we are getting the output as a kind of, you know, addition with the decoration. That's it. This is how we are doing it. Tanya, decorate result is the function calling another function as an argument to itself. Exactly. So the function parameter here is a kind of reference to or an alias to another function, and another function is nothing but add here. If you want to do the similar thing for say subtract, for example, this is the subtract. Maybe I can say subtraction, which is equals to P1 minus P2, and see, this is again going to do the job for subtract. So as simple as that, you know. So run this code and you are getting the similar result for subtraction. Yeah, it worked. But if you can recall what I said earlier, you are not calling the original function add and subtract. Rather, you are calling a decorate function, or you unnecessarily are changing your context, the line of thinking. So generally, when I say I want to call the original function add and subtract, I would really want to call add and subtract and not the other function. But you are changing your line of thoughts and you are saying, hey, call the decorate function, and then you will get the final result. Fine, it's working, but it's very hard for me to remember to call decorate result all the time and passing that add or subtract or multiply or divide as a parameter to the parameter to that function. So I want to simplify this. How do I do that? To simplify this, step number one is to change that decorate result function into a closure. To do this, probably I know these parameters will change. So I'm going to take these parameters out and we'll create a separate function, something like a def inner, and I'll pass those parameters to that inner and move the entire code inside the inner function. So the function will be only called once and the parameters will change. So I took those parameters which will change in inside inner function, and then because it's a closure, we have to say return inner. That's it. I changed my decorate result function into a kind of a closure. But because it is a closure now, the decorate result function will do nothing. It will just return a reference of inner function. So if I run my code right now, you will see nothing but a simple, oh, here now it's a decorate function not accepting 3, but accepting only one parameter, and that is something like a subtract or add function. But you see, I'm not getting any output there. I'm not getting any output because this is a closure, and a closure, if you want to use it, you have to get the result. So probably this is the result I'm saying, which is having a reference to add, and this is the result which is having a subtract reference inside it to that function. So now if I really want to get the output, we'll have to make a call to the inner. So result here is pointing to inner, where function is pointing to add, and result subtract is pointing to inner, where the function is pointing to subtract feature. Okay, so now here, if I want to make a call to that function, result add is pointing to inner. Inner is taking 2 parameters. Maybe those 2 parameters I can pass here as 10 and 20. And probably I can come back and say, hey, result subtract again 10, 20, and 10. So probably if I say run, you see it is still working right now. Vipin, can you tell me what is not, which part you're not getting, what is not understandable? If you can just pinpoint that, I'll just repeat it one more time. Have you understood at least till this line? So probably if you have understood till this line, there should not be any problem, because this is a simple closure what we have explained at least 3 to 4 times now. Okay, so this is the closure. A result add is pointing to inner function, where the function is pointing to add. One more time, let me come back to diagram. This is a result is pointing to inner function, which is nothing but this, where the num is pointing to 10. Similarly, result add is pointing to the inner function, where the function is nothing but add. So there we are taking num, here we are taking function, nothing different than what we have seen earlier. Now, why to take as a reference? Because I want to make a call to that function. Otherwise, what's the point of it? Okay. So earlier we were taking num, now we are taking function. Earlier we were passing 10, now we are passing add and subtract, and that's how we are taking the reference. Now, if I say a result and call that function, the inner function will call, because it is pointing to inner function will point, inner function will call, and inside inner function, num will take the value from outer function, that is 10. Now, if I say result add, because result add is pointing to inner function, there are 2 parameters we need to pass. Let's say I'm going to pass parameters like 10 and 30, for example. So that 10 and 30 will be passed to the P1 and P2. And inside of this, we are making a call to function. Function is pointing to add reference because we passed it here. That's the reason add function will get called with 10 and 20. And again, before you are calling that function, probably you are printing that stars. And after calling that function, you are printing stars. And that's how the addition result, you are getting it here. Similarly, when I call decorate result subtract, here we are calling outer 10, here we are taking num, here we are passing subtract, here we are saving that reference into a function. Again, when we say call that result, the inner function will get called, the num will print a value of 10. Here, now if I say a result subtract, and if I pass something like a 20 and 10, probably the subtract function will get called, and you see I'm getting the result of 10. 20 minus 10 is 10. So basically everything is working fine. All I'm saying here is, see, everything is working fine, but we have to write those 2 lines of code every time. I mean, I think the last iteration was simple because we were just using only 1 line. This time it has made my life a little bit complicated. Actually not. It has not made your life complicated, but it has simplified your life. Why? Because now if you have this closure here, and if you don't want to write this code on your own, all you have to do here is just go back and say, hey, I want to call that decorate result function. The decorate result is the name of my function, which itself is the closure, and at the rate something is called as the decorator. So someone was asking like, what do you mean by at the rate execute? Execute was the function I used earlier, and at the rate symbol will turn that closure into a decorator. That's it. You come back here and say, hey, I want to call a decorate result here as well. See, I'm not going to call decorate result. I'm not going to call decorate result and pass add. Instead, I'll call add function directly. So I'll say add 10, 30, and I'll call subtract function and pass 20 and 10. Magically behind the scene, this call will turn into something like this, or this call will turn into something like this, and the result will be seen. So basically you wanted to achieve that result. You have achieved it not by writing these 2 lines of code every single time. Instead, you are saying at the rate decorate result. Now, why at the rate symbol? This is how cookies work. This is how cookies cook. In a sense, this is how you are going to make the decorator in Python. It uses at the rate symbol. Don't ask why, because it is how it is. Guido Rossum has decided, so Guido Rossum has decided to go with at the rate symbol. So we are using at the rate symbol. Instead of asking why, say how. So how, it's very simple now. When you say at the rate decorate result, before the actual function get called, it converts itself into these 2 lines of code. And instead of calling add, it calls the decorate result by passing the function add here. It gets the reference of inner function. It calls the inner function and passes this, passes these 2 values. To be again on a very simple way to get these things done, maybe I can say add 40 and 50. And to be precise again, what does it do behind the scene is this. Again, it says decorate result. It passes this add, and right here, it passes those 2 parameters. This is the actual call it makes behind the scene. Exactly. So this is the way it does the job. And I see I'm not only getting my answer, but also I'm getting the actual decoration as well. If you just turn off this line, if you just say don't want to call this decorate result, you see I'm getting my original result. Add 40, addition 40, addition 90. Yeah, it worked. But if I want that decoration back, I want to come back here and see, hey, I got my decorations back. This is the way you can think of a decorator. I know it takes a couple of iterations to understand that. That's what I said earlier as well. This is one of the most difficult topics in Python to understand, probably for the first time, maybe for the second time sometimes. But once you understand that, believe me or not, it is the simplest topic in Python. You need to understand the logic behind it. You would not understand this if you wouldn't have understood something called as a closure. So those who have understood the closure, for them, it is exactly similar. The only difference is instead of you making a call to that closure, you are simply using at the rate symbol and the name of that function. Everything is getting done automatically here. So precisely, again, you are just saying at the rate decorate result, where the decorate result itself is a kind of closure, which is going to do the job behind the scene for you. Prerna, you have understood this. Does that mean decorator is not possible without having a closure function? Absolutely right. So decorator cannot be created, or decorator cannot be called without having a closure. Rather, decorator itself is a closure. In other words, closure can be converted into decorator with a specific syntax there. So that's how it is going to do the job. Adesh, your question. For us, we are calling our original function, but behind the scene, it's calling decorator function. Absolutely right. What you said, Adesh here. Behind the scene, I mean, we are calling this add directly here, but behind the scene, it's calling the decorate result function, and then it is making a call in this particular. I showed you both the scenarios. Like if you want to do it on your own, you still can do it. But if you don't want to do that, which is the reason why we have started looking at this concept in the first place. So probably you can just say that at the decorate result, and these two lines, line number 21 and 22, will be written every single time you call that add function. Or add function with passing the parameters there. Okay. Vipin, thanks for confirming that you got the concept. That's good. Adesh, for us, we are calling the function. It's calling decorator from function. Absolutely right. Ketan, closure is not possible without returning an inner, and the decorator is not possible without closure. Absolutely right. That's what I said. This is the kind of dependencies, guys. If you know function alias, you can understand what a closure means. If you what do you mean by inner and outer functions are? If you understand inner and outer function, you can understand the closure. If you understand the closure, you can easily understand the decorator. If you understand decorator, you can understand Flask. And if you understand Flask, you can understand the REST web services in Python. Because if you are planning to be a web developer, and if you want to be a server-side developer or the client-side developer, in both the scenarios, you would need to use a package called as a Flask. And Flask totally depends on only one concept, and that is called as a decorator. There is nothing in Flask other than decorators. So once we reach that point, you will see that all the times we will just write only decorators. We'll just call only decorators. That's it. We'll see that later. But this is a kind of a chain, and that's the reason why I'm spending enough time, so that those who are kind of going for their web development career using Python, for them it will be very simple. Even though you don't want to be a web developer, still understanding decorators, closures, and the function aliases will definitely help you not only in Python to understand the concept in other languages as well. There are many languages which are having maybe the inspirations from Python, like the annotations in Java, bunch of other examples, and you can understand those as well. That's the reason I generally put more efforts for you to understanding these two topics, closures and decorators. Most of the times people do not understand understand what happens behind the scene, and that's the reason for them it's kind of a little bit bouncer. But I hope now, with a little bit of more attention, you must have understood concept of closure as well as a decorator. Very nice to know that. Okay, so where we are, Rohit, can we have a single decorate function for multiple function at the same time? We did that. Did you see that? We are using only one function called as decorate result, and I'm sharing it, or I'm calling it for add, for subtract, and what else? If I want to go for multiplication, also we can do it there. If you want to go for divide, you can also do that there. What not? I mean, you can write only one function, and then you can use it all the times where we want to achieve something similar. So it's like, we are reusing that closure, or we are reusing that decorator for all the other functions where we need the similar decoration. Okay, so that's the main intention behind writing a decorator there. I hope you got the point there, right, Rohit? Praneeth, your question, you understood it thoroughly. Very good. Thanks for confirmation. Maybe Chandrakant, your question, is in the decorator we have to write at the decorator function only once? Yes, we have to write it only once, at least for now. I mean, there can be a decorators chain as well. We are not going in that details right now. If time permits, and if you are really interested in that, I'll show you that later, not right now. This is a kind of level 1. Just get the things understood at the level 1, and then if time permits, we'll go to level 2, where we can have decorator of decorator, which means a complex decorator, or the decorators chain. So which will have a closure of a closure. We'll talk about this later. But right now, this is the simple situation where we can, just understand how the things are happening behind the scene. Good. Okay, so thanks, Ketan, again for confirmation. Who's that? Parag, your course of action while teaching has been helpful. No problem. It's my job here to let you know, guys, in a better way. And that's what I'm trying to do. I'm trying to achieve. Anyways, that's good. Who's that? Forum, your question, decorate only use number. Decorate use only number. No, not at all. This is an example where we are passing numbers. Maybe later on, when we start using the next function called as a log, the logger, rather one of the best use cases of having that decorator, you will see tomorrow. So today you just learn how to write the decorator. In tomorrow's example, in tomorrow's session, I'm going to talk about few more examples where you can literally take the decorator to the next level, to the level where you want to, just go for doing something by writing 10 or maybe hundreds of lines of code. We'll simplify the scenario tomorrow. Those who want to be a testers and they want to learn the Python for testing career, for them this is going to be a kind of maybe a kind of a helpful function. Or if you understood this functionality, tomorrow you will see how you can turn it into a kind of a function or a kind of a decorator which will measure how much time it is taken to execute it, or how much time it is kind of giving you, or how much performance it is kind of giving you by using that function. I'll show you a couple of examples tomorrow so you will understand what is the real use case of decorator. Today I'm just telling you how. Tomorrow will show you where to use a decorator and how to turn that decorator into something usable. Okay. Prerna, I know it looks like around a round and round question, but still I have a question. Closure can be used with or without decorator, but always preferred to be as a decorator. Is that right? Maybe you can say it in that way, but other way I should say here is closure is an independent topic. Decorator, if you want to use it, then you have to go for a closure. So it's not like the closure is dependent on decorator, vice versa is true. Decorator has to be a closure. Other than decorator, you can use a closure separately, like what I've showed you earlier, to create that pattern or to generate the table and stuff like it. But when you want to write a decorator, the very first step is to create the closure. So it's like decorator uses closure, not the other way. Okay. Excuse me. Rohit, your question, not actually my doubt, but for every function we are writing decorate result that we can done only once for two or more functions. No, we have to write them separately. For example, if you're having a subtract, you have to write @ decorate result separately for subtract. If you are having a kind of another function like multiply or divide, then you have to write the decorate result there as well. So it has to be written separately for separate functions. But again, function name will remain same. Okay. Can we use decorate result only once? Yes, you have to use it only once for a function, not like you are going to put it common for all of these functions. That's not possible. Every single decorator will be associated with only one function at a time. So precisely speaking, again, if you want that add to have a decorate result function or decorate result decorator, you have to write it explicitly. There's no way you can, just club them together. So that's not possible. Okay. Who's that, Prashant? Please extend the expiry. Oh yeah, I'll do it today. I'm so sorry for that. I forgot to do it yesterday, but I'll do it today. No, don't worry, Prashant. I'll just reset the time, so you will get that. You will get the recordings again. Okay, not a big deal. Utpal, 1 year extension. That's not possible, guys, because that's the policy. Okay. Maybe did I? Ketan, I'll change it. Not a big deal. Tanya, there is a request. I want to make some of us will be having some final semester exams. So some of us are working professional. It would be great if you could consider that and make the video available for 10-14 days, because some of the people like me fall into it. Yeah, I know that, but that's the reason why I'm saying I'll reset these recordings video, and it will be available at least after 7 days when we are finishing the course. So it's like, after we finish the course, there will be 7 more days. You are going to see all the videos there. Okay. We'll talk about this later. It's not a big deal. We can take care of that later. But right now, you can at least focus on the technical side. Don't change the, don't change the context right now. Focus on this. Ask the question if you are having anything on the decorate result. We'll talk about expiry. Don't worry about expiry. We'll take care of that later. Okay. I'll take care of this later today. Don't worry about that. Okay. So you're having question, decorate result writing every time, every operation. Yes, it's necessary, and it has to be written only once when you are defining your function. Okay. So when you're defining subtract, you have to put it here. If you're defining add, it has to be defined here as well. That's it. That's how you can use the decorator. Anyways, so probably in today's session, we have seen how to write a decorator precisely. In tomorrow's session, we'll see where in the real world decorator fits, and how to use that decorator or how to take that decorator to the next level. Okay, so tomorrow is the practical day again, where we are going to see the real world scenarios where you can use a decorate result. And once we are done with that, we are going to start with object-oriented programming tomorrow. Okay, so be there, and probably before you come for the second session or the next session, please do some practice on this part. So tomorrow's session will be pretty much easier for you. Okay. Thank you very much, guys, again for attending today's session. I'll see you exactly at 8 o'clock tomorrow morning. Till then, have a very great day. Maybe have a not only great day, have a very good day as well, and enjoy the day. We'll see you tomorrow. Okay. Please practice on these examples. Otherwise, tomorrow's session will be a little bit difficult to understand. Anyways, thank you very much. I'll see you tomorrow. Bye-bye.